Today, wherever you are, all channels of communication has two things in common. One, coronavirus, aka Covid-19, and other, social distance. Hi, I'm Siva, Principal Engineer at Supermicro. Yes, we are at an interesting era of 21st century. We know a lot and we are zooming at rocket speeds, and today stand still with many questions than answers. One that may be obvious, is there any place not affected with? To answer that, yes, these are the 15 countries not reported any Covid-19 cases as on date. Some of these island countries isolated, social distance in nature, and other reasons we know. Before we were hearing machine learning advancements in all market segments, including medical, that brings immediate another question. Can we use or get help with? Yes, AI is helping Covid-19 by reducing test results time from days to hours. Medical teams are benefiting using X-ray and image classification. That is one of AML use case. Talking about AML use cases examples, here are few machine learning use case examples. Text-to-speech, language translation, language modeling, face detection, content creation, image segmentation are a few other use cases of machine learning. Along image classification, talking about image classification, let me bring my image classification example. So I'm going to Google Images. I'm going to grab some images. Let me put maybe a pet as dog. I'm going to copy. Okay, this dog looks like with mask. Let me try. Let me try passing to my inference engine, run inference. So it is detecting as dog, that's good. Let me go and get maybe this due dogs, copy image and see, run inference. It is predicting as dog, that's good. Let us go and grab a multiple dogs and see, making it complex so that whether it detects properly or not. So I'm running on these multiple dogs. It is predicting as dog, that's good. Let us take maybe some other image. Let us say a cat. Okay. Let us copy one of these cat images. Let us run inference. It is detecting as cat. Let us make it a bit complex. Take these multiple cats. Pass to the engine. Run inference. So it is detecting as cat. That's good. Let us go, instead of pets, let us go and take some other example. Maybe Supermicro logo. Let us take Supermicro logo. Copy this image. Run inference. It is predicting a Supermicro. Let us take a server, Supermicro server. It is very hard to see Supermicro's name. Maybe it is somewhere here. That is one of the advantages of machine learning, that once you train, even it is a human eye not able to see, but it is going to see and detect. So let us see whether my machine learning is going to detect that or not. So it is detecting. That's good. So maybe take another server of Supermicro. This is also hard to see. Run inference on this. So it is predicting as Supermicro. That's good. So coming back, this machine learning workflow, how it is working. The machine learning workflows are, there is two parts of machine learning. One is training. That is, you load the data and pre-process the data, supervised learning. and then you prepare a model. Once the model is ready, you deploy to production, and now that is inferencing. It is integrated trained models into applications. That is means once you pass the real-time data, and it is pre-process the data to filters the data and make sure the data is ready, and it submits the model and it predicts. That's the cycle. So for machine learning, end-to-end machine learning means training, inference, both together. And depends upon business case. Some businesses want to training only once because their business does not change much. So in only they use for inference frequently. So depends upon that. The models we prepare and we go from there. That is how the machine learning works, the same image classification. And going to details about Supermicro. We are founded and headquartered in Silicon Valley. We are in business last 27 plus years. As for IDC, we are recognized one of the 5 largest server vendors in the world. First to market leader in enterprise, cloud, and AI and edge. Our product lines range from edge to cloud, including latest technology, AI, ML, HPC, support working closely with the independent software vendors like SUSE and others. We also work closely with IHVs, independent hardware vendors, Intel, NVIDIA, AMD, and so on. To add few advantages working with Supermicro over competition, fundamentally, we understand every business is unique. We customize to your business needs. That brings wide range of product choice, product lines we carry. Not only that, we carry component level certification with ISVs that makes sure hardware is 100% compatible and meets business needs. To date, with any given ISV, we have highest number of certifications. That is a few of other advantages with working with us. Any POC or your business you bring to us, we work with you closely and make sure that it meets your business needs or exceeds your business needs. As I said, 27 years back, we started motherboards as a business. Today, we provide total solutions that is include compute, storage, and network end-to-end solutions. Talking about solutions, we build reference architectures. Our reference architectures are following simple design principles, whether compute, network, or I/O, secure, GPU, extra, and deployment consideration, easy, simplified deployment, serviceability, extra. We do integrate and test with following 3 steps. One, identify the requirement of use case, DevOps or high performance computing. Topology, we give 3 topologies, standard or balanced or advanced. So in advanced case, like you are advanced with technology and the latest and greatest. And if you are, for example, your scientific environment and research organization, you may want to latest and greatest technologies to predict and do that. Like that depends upon your business use case. Design considerations, we look for performance, density, redundancy, serviceability, and features like site-to-site connectivity and redundancy in data paths and so. And the third last step we do is integrate and test. In this, we do carry applicable industry standard benchmarks tests, and we make sure that it meets and beats the industry standard benchmarks. That is optimally. Coming to this total solution for SUSE AML platform. We built on using various components, and we leveraged SUSE's container as a service platform and Supermicro's between Ultra and Super storage and GPU systems. Of course, a combination of Supermicro and hardware and SUSE's CaaS platform is a highly modular Kubernetes product that gives customers the flexibility to start at the scale that makes the best business sense and effortless growth, a single cluster in storage, compute, and our node count. The flexibility gives business leaders a level of confidence in uncertain economic times that small investment now can grow without rip and replacing the existing environment. With a simple mouse click or command line in a UI, CLI commands, it can be changed to scale or scale up. CaaS platform is compatible with all hardware and software load balancers to provide redundancy for network connections, software process, and servers. Critical platform functions are provided triple redundancy in all paths, software, hardware, all recoverable automatically. And in this, coming to the various components we use the Intel second generation Cascade Lake CPU, NVIDIA V100 and T4 GPUs, of course, SUSE OS as underlying OS, sub-storage, Kubernetes, TensorFlow, Kubernetes, Qflo, and we go in detail. Node options, as node options, we have multiple node options. These node options, what I'm mentioning here is what we used in this POC, but we have various variety of products, and it depends upon your business needs. So we can use various nodes. To coming to this POC, what we used is for now master node and admin nodes, Ultra 1U and Big Twin. And worker node options for end-to-end, we used GPU 2029, which can accommodate 6 GPUs, and 4029, which can accommodate 8 V100 GPUs. And Ultra for inference 2U, which can also accommodate 2 V100 GPUs. For edge inference, we used a Big Twin that is can accommodate 1 T4 GPU also. So, getting in details of about Kubernetes, as you know, Kubernetes is an open source system for automating deployment, scaling, and management of containerized applications. It was originally designed by Google and is now maintained by the Cloud Native Computing Foundation. It groups containers that make up an application into logical units for easy management and discovery. And 90% of the world is using TensorFlow machine learning platform today. TensorFlow was originally developed by researchers and engineers working on the Google Brain team within Google Mission Intelligence Research. This is an end-to-end open source machine learning platform. Easy model building. You can train models easily using intuitive high-level IPS. And anywhere you can deploy robust in model machine learning production deployments, easily train and deploy models in cloud or on-prem or hybrid or the browser on a device. No matter what language you use, it is a language agnostics. You can use as any languages for your data scientist preference. Powerful experimentation for research, simple and easy to concept to code, state-of-the-art models and to publication faster. And another tool is Qflo lifecycle management. It is Qflo project is dedicated to making deployments of machine learning workflows and Kubernetes simple, portable, and scalable. It's a closely integrated TensorFlow, not only TensorFlow, it is Keras or any other machine learning tools, machine learning platforms. Can be integrated. To add one more clarification here, that this our architecture and SUSE OS also later SUSE PM will give more details of the tools what we can use. In this POC, we have used only TensorFlow and Qflo, these tools, but we can these platforms and hardware and OS SUSE can support various other machine learning tools and platforms. And there is which can be integrated and tested and can be deployed in production. Next, software-defined storage, we use Ceph. Various advantages because there's multiple objects. It can store object or block or file-based storage. So it's closely integrated into Kubernetes. It's a failover mechanisms, object storage, block storage, file system, whatever you need. Various benefits, of course, starting with cost-effective, low CAPEX and to hardware compatibility and low OpEx through failover detection, self-management and self-healing. Secure through client authentication and encryption test. That is one of the other importancy. And nowadays, when we deploy in cloud, security is one of the main concern. Everybody has and reliable and compatible and other things as it names. Putting together all these into design specifications, we have one rack design, admin nodes 519, master nodes 61U, and worker nodes GPU 2029, and data switches, two data switches and two IPM management switches, the two switches for IHA, and also, of course, it includes SUSE CaaS platform 3-year subscription. Rack integration service. We always work with closely with SUSE as we mentioned. Talking about GPUs, we have wide variety of GPU and product lines. To talk about that, let me bring Carlos, our GPU product manager, to go in depth about GPU server family and server systems. Carlos?
Okay, thank you, Shiva. My name is Carlos Weisenberg. I am a GPU system product manager, and I'm on the team that supports the GPU servers. So we are currently on our X11 GPU server generation. This is a Supermicro term. It aligns with the Intel processors. So that means that we are currently supporting the Intel Cascade Lake CPU. We're also supporting the latest GPU from NVIDIA, which is the Volta GPU. We've been doing this for quite a while, and so this is our 4th generation of specialized parallel computing platforms that are designed for HPC and AI machine learning. Because we've been doing this for quite a while, we have the largest GPU server portfolio in the industry. We've continued to see strong growth year over year, so we continue to invest and expand our product line. And we started out by selling mainly into parallel compute and HPC verticals like oil and gas, research and national labs. But in the last 4 or 5 years, with the advent of deep learning, we've seen large growth in the AI machine learning segment. So let's move on and let's start talking about our some individual platforms. Let's talk about our 2029 GPU server. This is a 2U server, very popular for AI machine learning. It's high density. It can support up to 6 V100 NVIDIA GPUs. It can also support the RTX 8000 GPUs. It's a dual processor, so it has can support 2 Cascade Lake processors with 3 UPI interfaces. And then finally, it can support up to 10 hot swap 2.5-inch drive bays, so it has a lot of capability for local storage. So very popular platform, very high density. But if we want something that can support much higher capabilities, our 4029 GPU system, it's also a very popular platform. This one can support 8 V100 GPUs in a 4U configuration. You can see the architectural drawing at the bottom of the slide. We have dual processors. We have 4 PCIe switches, and the 4 PCIe switches drive the 8 GPUs. The reason that we incorporate PCIe switches is because we start running out of PCIe lanes from the CPUs. And we want to make sure that all the GPUs are connected with PCIe Gen 3 by 16 links. With this configuration, we have very good balance between GPUs and CPUs. We have a very good thermal design. We have, the CPUs down in the bottom on the motherboard, and we have the GPUs a little bit higher. So we don't have any significant or any any air preheating for the GPUs. Because of this architecture, this has really been an industry workhorse. It's a platform that's been used by many of the GPU developers like NVIDIA and Intel and AMD to develop their GPU softwares. So these are some of the platforms that we support, and we have a wide range of GPU systems that are very well suited for AI machine learning. Okay, Shiva.
Thanks, Carlos. That is a wide variety of GPU product lines we carry. And talking about SUSE perspective of building the solution, it was pleasure to work with the SUSE in this and partner. To talk about this, let me bring Alexandro, Senior Product Manager, AI. Alexandro?
So thank you, Siva. So here's the how we are going to build a solution from SUSE perspective. So let me introduce about what we are doing at SUSE around the AI. First of all, we started from the foundational steps. And the foundational steps basically are about what we can provide to our customers and partners to start the AI project, the AI journey along with us. And of course, one of the most known capability of SUSE is the so-called SUSE packages that you can retrieve from SUSE packagehub.suse.com or from scc.suse.com if you are a paid subscription customer. In there, you will find a lot of new packages related to AI, and this slide is to summarize part of them. So if you just need to install and run a project that require TensorFlow or PyTorch or Python or RStudio or just Jupyter, that are all well-known application languages, frameworks from the AI perspective, you can just go to packagehub.suse.com or scc.suse.com, download them, install them, and we guarantee you that those went through a QI test that allows you to be sure that it runs on the version of the SUSE Linux Enterprise Service or SUSE products you're running on. That solution actually allows us to move to the next level that is even more interesting. So we thought that in terms of simplify, modernize, and accelerate, we have to make the life of a data scientist easier than what it is today. What we observed on the market basically was that a data scientist has spend a lot of time in configuring his own environment, configuring everything through the editors that he need to use, the frame he need to use, and how to deploy those into the infrastructure that eventually is what we showed us a little before. So the Playground solved these. So you can run on any OS, you can run with any tool, the editor, your favorite editor from data scientist perspective, any framework is a pre-built solution that has all the framework there, and any deployment. You can run against any solution, any data center infrastructure solution as AI platform in the backend. So in a nutshell, we observed two main use cases, the data scientist that I just described and the AI operator. So both of them have the same needs. I need a simple way to. And for the data scientist, building AI models without spending time to configure his own environment. For the AI operator, can be deploy the AI platform for his data scientist or monitoring the workloads, the AI workloads from that specific platform. Playground is there to solve this from a single point of entry. So if we define this as a reference architecture, then we can observe that you can either have GPU, CPUs, is a local environment, you can run on your favorite OS. And on top of that, you will get that through a container runtime, to a container, self-container solution, or as a SUSE data scientist virtual machine. Both of them will expose a web interface, the AI Playground, where you will find all the things that I just described before. Now, the Playground is very, very important because it works with another part of the AI solution, the SUSE AI stack. The SUSE AI stack simplify, modernize, accelerate, again, the life of the AI operator, of the DevOps. And again, what you can see here is that it can run on any hardware, any place, any deployment. So it's optimized for the infrastructure you're running on, Supermicro in our case. So we will work with Supermicro to get a perfect and optimized infrastructure that complied with any requirement from our perspective, from the customer perspective. You run on any place because you can run this infrastructure basically everywhere. But even more important, we automate the installation, we automate the configuration, we allow you to get immediately your job done without having to take any critical decision. We take the decision for you. So in a nutshell, this is the reference architecture we are going to release. In the version 1, we will focus on the Kubernetes side, on SUSE CaaS in our case, based on an operating system, SUSE Linux Enterprise 15 and above, with a specific hardware, Supermicro in our case, but supporting the most common GPUs out there, NVIDIA, AMD, Intel, and so on, with a specific platform, Qflo. Will be the first target, but we will add over time more and more platform, and also will expand the architecture to other kind of solution, like for example high performance computing, where again Supermicro will another partner to work with us. The high performance computing based on our solution, SUSE HPC, and again a platform like Jupyter Hub that we can use to run your AI workloads. And again, you can run SUSE containers or any containers that can apply within that. And if you look at the playground can interact with this version. And again, over time, we will introduce the storage and all the other capabilities that allows you to get the stacks in a way that you can use it and is flexible enough for you to switch any part of it and keep getting working. So there's no vendor looking as other competitors, for example, do there. So that is a nutshell what we good for SUSE stack and also from the playground.
Thanks, Alexandro. It was great to work with SUSE, and as we said, we work closely with SUSE and make sure that hardware and software are 100% compatible. And we both share the same vision that simplified, easy to deploy, easy to develop. That is one of the way we look forward to work. And Supermicro can customize systems that meet customers' specific requirements. Once again, to echo that all businesses are unique in their nature, so we can do your business case, we can POC the requirements. Supermicro can resell SUSE's design, deployment, and services. It is one-stop shop for customers. I hope you enjoyed joining this webinar. We thank you for that, and any POC or any requirements, you can reach us with these contact information provided here. Once again, thank you for joining this webinar.
Learn more at supermicro.com, powered by Intel.